All right, today we are focused on a supplemental lesson, actually, to section 5.6. So I called it 5.6.2, and it's the topic of linear equations. So this should be a bit of a refresher from some Algebra 1 classes. It says writing linear equations, and the form that we're focused on today is slope-intercept form of a linear equation. And this slide gives us slope-intercept form in two different notations. The first one, and probably the most popular, y equals mx plus b, where m, the coefficient of the x term, is the slope, and b, the constant, is the y-intercept. Now the other form that they give us is y equals a plus bx. Now this is the exact same slope-intercept form, it's just that they're using different letters to represent the slope and the y-intercept. B in this case is the coefficient of the x term, so it's now the slope. And a is the constant, so it is the y-intercept. Right? It's important that you don't get confused between these two forms. They're sort of slightly rearranged and slightly written differently, but they are both slope-intercept form. So on this slide, I give you 4 examples of linear equations that are in slope-intercept form. So let's go through them one at a time. So the first one that we're going to take a look at is the blue graph. So I'm looking up here at the equation y equals 2 plus 3x, and you can see the blue graph right here, and they even label it as y equals 2 plus 3x. So looking at that line, we see that the y-intercept, the constant, is 2, and the y-intercept of the graph is 2. We see the slope, the coefficient of the x term, is 3, and we can find the slope of the line by going from this point and rise 1, 2, 3, and run 1. So rise over run is 3 over 1, which of course is 3. So next we're going to look at the red graph. The red graph has an equation of 2x minus 1. And we see on the actual graph, here's the red graph, right? And they give us the equation again. The constant in the equation, -1, that'll be our y-intercept. And we see that right there, y-intercept of -1. And our slope, coefficient of the x term, is 2. And we can see on our graph, from this point, we rise 1, 2, and we run 1. So slope of 2 over 1 is a slope of 2. Continuing on, we take a look at the yellow graph next. I don't have yellow as a color, so I'm just going to use black in this case. Y equals -3x plus 4 is the equation we're looking at. Over here, we have our graph and our equation. Again, we see the constant of +4 corresponds to the y-intercept of +4. And we have a slope, coefficient of the x term is -3. And we can find our slope by taking a point here, and we rise 1, 2, 3. That's going down, so it's negative. And we run 1 to the right, so that's positive. So we have a rise of -3 and a run of 1. Well, -3 over 1 is -3, so that's our slope. And then finally, we have the green graph. We have the equation y equals -5 plus 3/2 x. Looking at the graph, there's the green graph, of course. And the equation, our constant is -5, and that is our y-intercept right there, y equals -5. And our slope is the coefficient of the x term, +3/2. So we can find our slope by going rise 1, 2, 3, and run 1, 2. That's a slope of 3/2. So now we look at our first example. We're given a graph, and we're given some information. We can see that point A is the point 0, -2. Point B is the point 4, 1. We have a rise of 3 and a run of 4. And we are being asked to find the equation of line AB based on this information. Well, this should be a fairly easy problem to do. Remember, slope-intercept form, y equals mx plus b. Our slope is our rise over run. So looking at our graph, we have a rise of 3 and a run of 4. So our slope is going to be 3/4 x, right? The slope is 3/4. And the y-intercept, we can see right here, that's where the graph crosses the y-axis, right? We also know that because the x value, the x-coordinate, is 0. So our y-intercept is -2. So I can come over here and do -2. And there's my equation. Y equals 3/4 x minus 2. Our second example, similar but slightly different. Here we're being given points C and D, and we're being asked to find the equation of line CD. So, of course, y equals mx plus b. Let's start by finding our slope, m. In this graph, they don't give us a rise over run. We certainly could count the rise over the run because of the grid marks. So we could start at point D and rise 1, 2, 3, and run 1, 2, 3, 4, 5, 6. So that's a rise of 3 and a run of 6. 3/6 would be our slope, but of course that reduces to 1/2. So our slope is 1/2. The other thing that we could do is we could use the slope formula, and I think it's important to review that formula here. So let's do that real quick. Our slope equals y2 minus y1 over x2 minus x1. So if I call C my second point and D my first point, then y2 is 6 and y1 is 3. So I have 6 minus 3 over x2 is 4, x1 is -2. I have 4 minus -2, and I get 3/6, which again reduces to 1/2. So either method of finding our slope in this case is going to work for us. So I can write y equals 1/2 x, and now I just have to find my y-intercept. And luckily, on this graph, that y-intercept is very clear, right? That y-intercept is at 1, 2, 3, 4. So I come over here and put plus 4. So the equation is y equals 1/2 x plus 4. And then finally, one more example. Find the equation of the perpendicular bisector of the segment with endpoints 2, 9, and -4, -3. So this is the given segment, and we're being asked to find the perpendicular bisector of that segment. So this is going to require some previous knowledge. Remember the relationship between slopes of perpendicular lines, right? Slopes of perpendicular lines are opposite reciprocals. So what we can do here is we can find the slope of the segment. So let's use our formula for slope, y2 minus y1 over x2 minus x1. So I'm going to call this my first point and this my second point. So y2 is 9 minus y1, which is -3. x2 is 2 minus x1, which is -4. And I simplify. 9 minus negative 3, same as 9 plus 3. I get 12. 2 minus negative 4 is same as 2 plus 4, which is 6. So I get a slope of 2, or 2 over 1. So if that's the slope of my segment, then the slope of the perpendicular bisector is going to be the opposite reciprocal. So if this is really 2 over 1, the opposite reciprocal will be negative 1/2. So this is actually the slope that I want to use for the equation of the perpendicular bisector. So I'm just going to set that aside for now. I know that that's my slope. I'll come back to it in a few minutes. Now I need to focus on finding the y-intercept. Well, looking at this graph, it looks like the y-intercept might be at 2.5, right? But how can I be sure that that's the y-intercept? What if that's not 2.5? What if it's 2.6 or 2.55, right? I don't know for sure. So I'm going to use some calculation to figure out for sure that that's the y-intercept. So let's go back to our y equals mx plus b. We know the slope of that perpendicular bisector is negative 1/2. So let's plug that in. Negative 1/2 x plus b. I need to find the y-intercept. I need to find this value right here. What I can do is I can choose a point, xy, that I know for sure is on the perpendicular bisector. So for example, this point right here, I know that point for sure. It's obviously negative 1, 3. So I'm going to use that point and plug it in for x and y, and then solve for b. So y is going to equal 3 because of that 3 right there. So I have 3 equals negative 1/2 x. Excuse me, I want to plug in for x. And I know that x equals negative 1 because of that right there. So let's do times negative 1 and then plus b. Now I have an equation where b is the only unknown and I can solve for it. So let's solve. 3 equals negative 1/2 times negative 1 is positive 1/2 plus b. And now in this case, I'm going to subtract 1/2 to the other side, and I'm going to get b equals 2.5, or 2.5. So it does end up that the graph, while it looks like 2.5, it indeed is 2.5. But better to be safe than sorry, right? We went through a process of calculating that y-intercept, so we know for sure that the y-intercept is 2.5. So I kind of set that aside, and now I have my two pieces of information to write the equation y equals negative 1/2 x plus 2.5. And that's the equation of the perpendicular bisector of the given segment.